Our last speaker today is Martha Lewis. As head of materials at Henning Larsen Architects, Martha has established an office-wide material database identifying healthy, ethical, and environmentally tenable materials. Martha is a key proponent of and a rigorous thinker in understanding what actually goes into the materials that we specify and use in our industry. She will talk to us about minimizing novel entities, construction product selection respecting planetary boundaries. Martha Lewis.
Thank you very much, Reike, and good morning to you and good afternoon to other ones. I'd like to start by telling a small story about one morning when I came outside of my apartment. Next door, the school was having their playground renovated. And in front of our entryway were 3 huge barrels that looked very much like these 3 barrels. And the label was actually identical. And I could see this human health hazard symbol and danger warning and flammable warning. And I thought, well, that's interesting. What's going to happen on this playground for elementary school children? And being the safety data sheet nerd that I am, I took some photos, ran home, and double checked. What is this stuff that's coming out on the playground? And it turns out that it's a substance that gets mixed up with rubber. And when you read the safety data sheet, it says that H350 may cause cancer, H360 hazard code may damage fertility of the unborn child. This is the kind of design decision where I think we've become incredibly good at living with an extreme disconnect. This product, on top of it all, is called safety surface for playgrounds. So who wouldn't want to spec a safety surface? And we're very far away from understanding that the impacts, these hazards, actually have consequences. We just have been informed that when this product hardens and the children come flying down the slide and land on it, it's very good for the absorption and they won't have any broken ankles, which is also very good. But what about all the other stages of this product's life cycle? What about the production of this chemical? What about the workers who were putting this out without any kind of protective gear? What about the children who are playing next to this, breathing the fumes, which are also indicated with the hazard code as harmful if inhaled? This is in Copenhagen. This is in the center of Copenhagen, and we're not following the regulations, and we're working with very problematic substances. But we've become incredibly good at the disconnect. As long as it works in the user phase, it's okay. And that's what I'd like to talk to you about today, because it's actually not really working for us. Novel entities. What are novel entities? Novel entities are part of the very interesting work that's coming out of the Stockholm Resiliency Institute, defining the 9 planetary boundaries. Where is it that we step beyond the safe operating space of the planet and push the planet's boundaries in a way that is extraordinarily problematic and jeopardizes future humanity on the planet? So novel entities is a somewhat fancy and somewhat misleading word because it actually sounds like something positive, but it's something that entails 3 different aspects. And one of them are synthetically manufactured chemicals, like the ones we just saw in the barrel. The second one is heavy metals that are used in human processes. For example, lead in paints or cadmium in color pigment. And the third is microplastics. So all sorts of elements of pollution, global planetary pollution, that are not part of the other 8 planetary boundaries. And these novel entities were recently quantified by the researchers at the Stockholm Resiliency Institute, this past January, and they've come out with a report indicating that it is really a very serious crossing of our safe operating space, that the global chemical production, it has increased 50-fold since 1950, and that it's projected to triple again by 2050 compared to 2010. The United Nations Environmental Panel issued a report in 2019 saying that their goals for reducing global chemical usage for 2020 could not be achieved, that the 2030 goals were in jeopardy already. They could see it in 2019. And the real question for us in the built environment sector is, why exactly is this relevant? We do have certain chemical products, but there is a fairly daunting statistic, and that is that the construction sector consumes 28% of global chemical production, making the construction sector the #1 end market for chemical consumption. The other aspects of pollution, in particular, novel entities, are in our sector, and the construction sector consumes nearly 20% of the plastics used in the EU. So microplastics and plastic waste are really quite an issue for our industry. And another fairly overwhelming report came out also in January of this year, indicating that 58% of microplastic leaked to the ocean is from paint. So radically high number. The previous studies had indicated that it was a much lower percentage of microplastic in the oceans. But this latest study from the Environmental Action Research Organization in Switzerland indicates that paint is actually far, far higher than understood before. And architectural paint is a good part of this. So what I've always thought that if you just present people with the facts and with the statistics and with the numbers, then this is the start to the catalyst to making some kind of change in our behavior. If we just address this question of perhaps limited knowledge or perhaps limited understanding of the extent of the problem. The Resiliency Institute's report was a really fine way of raising the finger and saying, are you aware of this? And what I'd like to do is do a similar approach in the building sector here. And I look very specifically at data that's used that indicates usage patterns of our industry, the construction industry, in order to point very specifically at the overwhelming number of hazardous substances of very high concern that are in use in the EU. So we do have a very interesting reporting database in the Nordic countries called SPIN, Substances and Preparations in Nordic Countries. And here you can look up after usage category. So you can isolate these circa 13 different usage categories that indicate chemical usage in construction relevant usage areas. For example, reading from the bottom of the list, and that is also the bottom of these graphs that show usage of REACH's substance of very high concern and the old Danish loose list over undesirable substances. Reading from the bottom of the 4 countries here, I start with Denmark. We have adhesives and binding agents in blue. So a lot of substances of very high concern are used in this particular product category. And the green indicates construction materials. There are fillers, and then non-agricultural pesticides and preserves in the dark purple. And looking through the countries, we can see this is usage per year from the year 2016 up to the year 2020, the last year where there is data reported in the SPIN database. But we can see we're at pretty high numbers for Denmark. So this past year, we were around a little over 17,000 tons of substances of very high concern and loose substances used in these building product categories for production of products in Denmark. And it's not looking better in Sweden. Finland is showing some interesting developments over 5 years with great reductions, and Norway is bouncing around up and down. In general, there's a slight indication for a downward trend of the usage, but we're still talking huge amounts, huge tonnage use of these chemicals that are declared extraordinarily problematic, that REACH is focusing in the regulations in the EU to try and get them onto the authorization list and then slowly phase them out. But this is with a lot of emphasis on the word slow. If we take another list, if we look at Living Building Challenges Red List, which has 5,770 different substances on it, we can see that the use of these particular substances on another red list are actually even higher. So the use in Denmark in 2020, the last year, puts us up around 22,000 tons of the substance of very high concern on the Living Building Challenges red list. And I could just point to a few here. We have bisphenol A in the light green at the bottom of the charts, and then we have added formaldehyde in the dark green, and in Sweden, the dark blue is chlorinated polymers. These are all substances that have some of the worst impacts, such as they're carcinogenic or they're mutagenic or toxic to reproduction, skin sensitizers. They're highly problematic and dangerous in the aquatic environment and to living organisms in water, etc. There is an agreement on what is a substance of high concern in the EU regulation. Use of PFAS, para- and polyfluoroacrylic substances in construction products, is also something that where legislation is lagging a little bit behind, and where if we look into the SPIN database, we can see, okay, the usage in the 4 Nordic countries is higher than it should be for what we call the forever chemical, the chemical that has an extraordinarily long life, is very persistent, is suspected in terms of increasing the risk of kidney or testicular cancer, indicates potential for increased cholesterol levels, decreased vaccine response in children, changes in liver enzymes, et cetera, et cetera. So something that we really have a societal interest in minimizing these impacts, because they have huge societal costs in terms of trying to fix these health issues. But we have a heavy use of this, particularly in Sweden. Finland has 0 use, I will say, and it bounces up and down in Denmark at fairly low levels, but we are looking at a handful of tons each year and up around so 40 tons or so a year in Norway. And the use isn't really decreasing over the 5 years. In fact, in Sweden, well, it bounces a bit, but we're not really, the PFAS hasn't come actively into regulations. So it's a bit of a wild west with the PFAS in construction products. And they're in all sorts of construction products. They're in binders, and they're in adhesives, and they're in surface treatments, and they are in flame retardants. And it's something that, until there's regulation, until we have transparency, it's very hard to, as a practitioner, begin to address. One way to address it is to use a certification system. But also here, we're simply not targeting in the certification systems the substances that need to be targeted. So looking at this is data from 2017. In Denmark, there were around 20,000 tons of substance of very high concern used in the country in construction products, but only 3% of these, in terms of volume, could have been targeted in a DGNB screening. And it's a little bit better in Finland, because this is using LEED requirements. In Finnish projects, you could hit about 16% of the volume of substances that were used in 2017 in Finland. Sweden looks a little bit different because of the way that consultants are asked to screen projects. You don't work with a red list, but instead you work with the hazard codes. So you cannot have carcinogenic or mutagenic or toxic to reproduction. So looking at these properties is actually a very interesting way in order to target a wider group of chemicals. So the question is really how do we as practitioners navigate this where we don't have the information we need, we don't have the knowledge we need, and in many cases we're simply not aware that this is, we think with blinders on, we think, okay, it's fine in the use phase. If it's fine in the use phase, that's where my responsibility lies. We'll take care of worker safety. That's part of the legal apparatus within which we operate. But again, there's this huge disconnect. We don't think about communities that are impacted at the site of production of these chemicals. We don't think about potential in terms of what if these products are reused in another process, or reheated and then reconstituted for future circular reuse of products. So all of these other aspects are a little bit off of our table, and we don't have the information to navigate well. One of the very good ways to navigate is to understand that this is the core of what should be in a specification, what a client should demand, that we do not work with these properties that are very problematic. So we should eliminate substances based on their properties. On the left, you can see the properties that I've been citing: the CMR, carcinogenic, mutagenic, toxic to reproduction, endocrine disruptors, particularly hazardous heavy metals, cadmium and lead, etc., persistent bioaccumulating toxins, etc. And then this comes out of two charts from BREEAM in Sweden, and these are phase-out properties on the left as defined by the Swedish Chemicals Agency, and on the right, the risk reduction properties. This is a very condensed way of putting something into your specification and saying, we don't want this in the project. And then you pass it along to screening. As a practitioner, you should screen in your planning process, but certainly on the site, contractors should also be involved in this screening so that safety data sheets are used so that you simply do not have these problematic properties on site. One of the ways that really supports practitioners in knowing what is in the products is safety data sheets, as I've mentioned, but in articles that don't have safety data sheets, we need to have product health declarations coming out of the US, the HPD, or in Sweden, now over 25 years old, the building product declaration. And with the Living Building Challenge, you get another very fine label declaration called the Declare label, where you can see what are the hazard phrases, what are the properties, perhaps the problematic properties that we actually don't want in the products that we're using in the project. And in general, we need to raise our level of knowledge, raise our increase education, particularly for these chemical classes where legislation is really a little bit slow. It's not proactively getting PFAS out of building products at the speed that it really should be. So then we step in as consultants and say, listen, we need to be very proactively screening our construction projects for PFAS. And I recommend this extremely well-written report by the Green Science Policy Institute. It's exactly what practitioners need in order to have a better understanding of where are PFAS, in what products. And then not only that, but suggesting alternatives, because if you hear you can't use this particular kind of coating, what can you use instead that might have similar performance qualities? Back to those paints and that microplastic, which is a big part of the novel entities. 48% of global paint-related plastic pollution is from architectural paints. So this is architectural paints that have a plastic binder or a polymer-based binder. So this is the acrylic paints, the latex paints, all the paints that kind of came in as this second generation of healthy paints, replacing the ones with the high solvent content, water-based, etc. But the impacts of from the architectural paint sector are actually quite high. So we have a lifetime on the screen here, and this is coming straight out of the report I mentioned before, the EA Environmental Action Report. So these come out of interior paints, that comes out of exterior paints on concrete, exterior paints on wood, and there are a variety of end-of-life possibilities, and the impacts to the environment come from all the phases. So it comes from production of the paint, it comes from application, it comes also from wear and tear in the use phase, and then also from the end of life. So whether it's landfilled or recycled or dumped or incinerated, the impacts to the environment are that 25% of architectural paints are then leaked to land, and 8% is leaked to waterways. This is a huge kilotonnage of leakage per year. So if you could do just one thing differently, just one thing to take a step in the right direction, it would be to reassess what kinds of paints you're speccing in your project. It's that thin little layer, but it apparently has huge consequences. So instead of speccing the usual suspects, the latex and the acrylic, look instead at alternatives such as linseed oil, clay paints, lime paints, silicate paints. Try and see what is the binder in this paint and figure it out. Is it a plastic binder? Is it a polymer binder? We essentially need to, in order to do this huge radical transformation, we need to make some radical changes that really hurt because they're so drastic. We have to reassess our material economy. Today, I've been speaking primarily about hazardous substances. However, decarbonization, huge issue, something I talk about every day. We need to move away from this extraordinarily fantastic use of materials that has delighted us for many, many years and is extraordinarily beautiful. However, we need to reassess the material economy that we have been using, this mineral-based material economy, an extractive material economy, and we really do need to look more closely at a bio-based material economy. And some, perhaps not all, but some of the challenges with substances of very high concern can also be addressed in this transition, where we look at our historical building techniques where there at that time were not this huge parcel of substances of very high concern 100, 150 years ago. They just didn't have it, so it wasn't in use. What was in use and how did we protect straw from fire before we had flame retardants? We need to be inspired by our historical traditions. And in general, we need to take a look at this Venn diagram that we've all become very comfortable with. This is the code diagram for a sustainable certified system for buildings, for example, used by many of the sustainable certified LEED or BREEAM or DGNB. And if you just had a balance between people, planet, profit, between the social, the economic, and the environmental, then you would have a sustainably certified building. But we can see, because of the incredible breach of planetary boundaries, that this is actually not really the case. And we need to reassess this diagram. It really needs to look more like this, so that we prioritize one of these over all the others, because unless we prioritize what is impacting the planet, we do not have a long future on this planet. And if we do prioritize, then we have the possibility to continue our inhabitation of the planet and thereby also to continue our prosperity. Thank you very much.